Hello everyone, my name is Josh with MG. In this short video, I will be showcasing what MG can do to enhance your Civil 3D workflows. Through our design process assessment, MG will analyze your project process from its earliest conceptual phase through project closeout. We'll leverage this knowledge to work with you to implement industry best practices, templates, standards, improved workflows, and a professional development plan to take your efficiency to new levels. Build your competitive advantage, and deliver a better product for your customers. We understand that in today's work environment, remote work is more prevalent than ever. Our expertise with both BIM 360 and the Autodesk Construction Cloud collaboration technology can assist you in automating tasks and connecting project information and people in real time as a centralized source of truth for improved decision making. Each product is supported by a common data platform, ensuring transition between each project phase and team is handled with ease. Look to us for insight in connecting your GIS data with your Civil 3D design workflows onto construction and finally project closeout. MG also offers Pro Civil 3D tool packs that can enhance the functionality of Civil 3D, AutoCAD, and Revit. With a 70-plus year legacy and a footprint in 42 states, MG is the leading partner and expert in providing custom, fully integrated software solutions for engineers. I hope you choose MG to work with you to disrupt the status quo of design technology innovation.
Welcome to today's session using open source data in design, presented by Josh Mercer. A little bit about our presenter. Josh is a senior engineer at KL Engineering with over 10 years of professional experience. He graduated from UW-Madison with a civil engineering degree in 2010 and has proceeded to cut his teeth on Civil 3D projects, including the I-39 mega project. Throughout his career, he's worked on a wide variety of roadway design projects, all delivered using Civil 3D software. Recently, Josh began working on numerous parks and shared use path projects, which has led him into the realm of using open source data, and he's going to be sharing some of the tips and tricks that he's learned with us today. My name is Mark Degner, and I work with AECOM, and I'm going to be assisting with the Q&A moderation and have just a couple of notes before we get started. First, we want to give a big shout out to all of our sponsors for helping make this workshop happen. Also, at the end of the day, there's going to be a link to our evaluation form. Please fill this out and help us to improve our event. Also, completion of the evaluation is also necessary to qualify for PDH credits. Now let's get started with today's session.
Hello everyone, and welcome to this presentation on using open source data in design. As Mark kind of got into already, my name is Josh Mercier. I'm a senior engineer at KL Engineering, over 10 years of experience. Work out of the Madison office. Started out kind of working on highway design projects and have more recently moved into parks and trail design projects, which has kind of led me into actually exploring the use of open source data in my design projects. So a quick outline of the presentation. We'll get into the different types of data available, discuss the sources of that data, run through a couple of examples of current and past projects that I worked on, and then close out with some question and answers. So what types of open source data are available? There's imagery data, of course. This can range from TIFF files, PNG files, JPEGs, SID files. Typically, they will have their geolocation within their file, so you can just bring it in correctly into AutoCAD, and it'll be coordinate correct in your drawing. Also available that is typically pretty useful is our surfaces or elevation data. This will come in multiple forms. What we're looking at today and what we're preferably looking for in general are either shape files for contour lines. Sometimes they have contours in DWG format. Once in a while you get lucky and get an XML surface, but also available, which we won't really go into today, but I'll just discuss briefly here, are LAS files or DEM files that come in different kind of file extensions. And those types of files you'll either need to use InfraWorks or something to get a usable surface out of, or you could work with someone in your office who has an understanding of GIS and access to Esri GIS software to get some of these files into a more usable data for a Civil 3D user. So then other available sources include survey data like right-of-way lines, property lines, section lines, monuments. Again, usually this is in shapefile format or possibly DWG. Floodplain mapping we'll get from FEMA, that's in shape format as well. Watershed mapping and existing infrastructure like road edge, storm sewer, utilities, that kind of data is typically in shape files as well. But once in a while, you'll get lucky and get it in DWG format. So what are the sources of this data? I would say the first spot you want to start when you're looking for any open source data is to go directly to the municipal GIS websites. So that's your county, your city, village, any locality, any municipality will have some GIS websites and hopefully have open source data. If they don't have anything obvious, you can always reach out to the actual GIS person who is keeping tabs of that data and see what they're willing to share with you, if anything, and just ask questions and people will help you out. So if you can't find anything on any GIS website, you can always go to these other two websites. There's a State Cartographer's Office, which has LiDAR data on it, which we'll run into here quick. So if you read through these, they'll pretty much tell you exactly where their data is from and what they're going to give to you, and how old it is, and any kind of information you want. If you dig into it a little bit, you'll get what you need to find. So you can click on any one of these counties and this pop-up will come up and say, okay, you could go to Wisconsin View LiDAR and you can say they've got a couple different years. It'll kind of run you through what they have available and provide links. You can also go to the Dane County LiDAR or directly from Dane County GIS. So this is another spot to look if you can't get anything out of a GIS website. And then the Wisconsin View Data Portal is another source which has aerial and LiDAR information. So you can see here, you can choose aerials, LiDAR. You go into whatever you want, and then it'll tell you kind of what they have available, what years they have available, different sources of the data, and different, you're looking at geotips here. So if we went into Dane County and you can read through this, it'll tell you what their coordinate projection is, how to download it, what it's going to turn into, and it'll give you a quick rundown of what you need to actually get it into a file that you can use it. So I'll let you guys look into that stuff as you actually get into it, and won't cover that today. Again, so FEMA is a source. We'll get our mapped flood hazard data from there in an example later, and then you can always check out Wisconsin DNR website to see what they have available. They've got watershed data available. They have soils data and wetland indicator data available for use within Civil 3D, and typically all of their stuff is going to be in shape files. So with that, we'll run through some examples. I'm kind of cheating here, going with two examples from Dane County, Milwaukee County, and their GIS websites are actually super user-friendly, very easy to get data out of, and we'll go into that right now. All right, so let's hop into the first example here. This is for a City of Madison Garber Path project that I recently completed. What we wanted to do was we wanted to get some aerial information, some LiDAR information prior to actually getting survey out there. So I went to the Dane County website to download that stuff. We'll show you that right now. So you go to Dane County GIS, and then you scroll down to where they have a GIS data download app. You get that app started up. And you see on the left here, it gives you step-by-step directions on how to get what you want out of this site. So you'll zoom in to wherever you want the data from. We'll get the aerial first. Just click what you want. I'll take you to a tab, or it'll allow you to download a zip file. I'm not going to download the zip file now because it takes a little time. I already did that, but you can save it however you want in your file structure. So that's done. Then we'll get the LiDAR data following this set of steps. So we'll click on this down arrow here. Choose whatever shapefile we want, contours, 1 foot intervals, and then we'll select our area that we want, and then you would just hit run here. I already did this and downloaded it. Again, it takes a little extra time to do it, so I'm not going to run through it now. But again, you could just save the zip file wherever in your file structure and then extract, and it'll be ready to use in Civil 3D. So let's go to Civil 3D. So the first thing we want to do in these files when you start out is to make sure that your coordinate systems are set up correctly. So we'll come in here, we'll go down to the WisDOT options, and we'll find the Whiskers, Dane County, US foot. Hit OK. We're good to go. So the first thing we'll do is bring in the aerial. There's a couple different ways you could do it. So first way I'll show you is via the data connection with the raster. You can change the connection name if you want, doesn't matter. You click on the picture and you go and you find wherever you saved your TIFF file. Hit open, connect, and add to map. Give it a little bit of time. There, it's added in. That is coordinate correct. Should be good to go. Moving around in these files gets a little rough sometimes just based on the size of these TIFF files. So you have to be a little bit patient. So in order to manipulate this raster image, you want to get into the map WSpace task pane and go into the display manager. And here you can select your TIFF file. You can go into the style. You can change its brightness in the drawing. Change it back. You can also change it to a grayscale, which is handy for when you're using this for WisDOT projects, then you can plot sheets with your aerial in grayscale. Definitely, if you're going to make any sheets, and use your aerial in those sheets, I would for sure use this data connect option versus actually attaching the image. If you attach the image, the plots tend to wash out whenever you try to plot that aerial in a sheet. So this is the way to go. I will show you how to do the XREF just as an alternative, because you can kind of play with what the aerial looks like a little bit better. So to get that reference in coordinate correct, you want to use the map insert command, and that'll cause this image to come in coordinately correct in your space. And now that the image is in here, you can turn it off, turn it on, you can adjust the fade and all that kind of fun stuff. But we don't need this for now, so I will detach. And then we'll go into looking at the shape file and getting the contours in. All right, so to bring in that shape file with our 1 foot contours, we're going to use the map import command. You're going to figure out where you saved that. Select your 1 foot intervals, say OK. It is going to come into the coordinate system that you have set up, and before bringing it in, you're going to want to go into the data column here and include create object data for this file. And say OK. And then hit OK. And it'll bring these in. So these are now in the file as 2D polylines. They currently do not, you'll see in the properties, they do not have any elevation data yet. But you can see down here in this properties tab, it's there. We just need to get it out and into the actual polyline so we can make our surface from these contour lines. So what we'll do is we'll save this. I'm just saving it. Save it however you want. Saving as a shape import. Then you're going to make sure you close this file and start a new drawing. So we'll patiently wait for this drawing to open. The one thing I will say is that we're going to be in the map W space, the task pane again, and we'll go through how we're going to use that in order to get our polylines in here with elevation data associated with them. So instead of being in the map or the display manager tab, we'll go into the map explorer tab. And what we'll want to do is we're going to drag and drop our file into here. So this is the file that we just imported the shape file into. Drag and drop into drawings here. So now it's connected to this drawing. Before we do anything else, I'm going to make sure that our drawing settings, our coordinate system is set up correctly. All right, we're good to go. So we come into the query and we're going to define a new query. First thing we want to do is make sure that all of our polylines are going to come in. So we're just going to say all. We want everything to come in, and we're good to go. We're going to have it as a draw. And before actually executing, we're going to alter properties. And we want to alter the elevation. To do that, we'll select elevation here under select property, and you go into expression. You're going to come into the object data, and you're going to select the elevation field and say OK. And then we're going to add this into the current property alterations and hit OK. And then we're going to execute this query. We're going to zoom extend, so great. So this came in coordinately correct. And we will see that they now have elevation data in the properties of the polylines. So we're all set to actually make a surface. So we'll come in, we'll make a new surface. I always like to say e.g. LiDAR. In description, I like to put in where this came from. Just so for records keeping, you know what's what, where it came from. I also like to make sure that something happens when I make a surface, so I change the style right away. Hit OK, come back in here, select my surface, go into add data and contours. I always keep the kind of the general settings as they are out of the box. Hit OK. And then I'm just going to select all of my contours there. All right. So let's see what we got. We've got min and max elevations, so that's a good sign. You can change this into whatever setting you want. I'll go 5 and 1. And you see that generally speaking, your contours match exactly the contours that you got out of that shapefile. So that's good. Now, there will be times where you'll get, excuse me, you'll get your surface out of LiDAR, and you'll actually want to convert those elevations onto a different datum. And there is a way to do that relatively easily. So let's say City of Madison had a datum and it was, 750 feet lower than the elevations we got here. We can do that, make that change fairly easily. We're going to create a new surface. We'll say EG LiDAR city data. Then we're going to say City of Madison data. We're going to say OK. You're going to select that surface that you just made. And you're going to paste your other surface into here. Hit OK. All right, and then from there, you still have that existing LiDAR city datum selected. So you come back into Edit Surface, and you could just raise and lower surface. And it asks how much to add to all elevations. So to bring it down the 750 feet, you're just going to type in a negative 750, and you should be good to go. So I'll turn off this surface. And we'll select our other surface, and you'll see that our minimum elevation is 95, and our maximum elevation is 116. So now, the next thing we want to do is to get some mapped flood information in here, some floodway information into this drawing. So to do that, we will go to the FEMA website. All right, so to get our FEMA flood maps, we'll go to the FEMA website. In the National Flood Hazard layer, there's two ways to access. I recommend going with the ArcGIS viewer. It's just simpler to get out what you need. So that'll bring you to a GIS, web-based GIS application. You just zoom in to where you want to get the data out of. Now with this, you can actually only really download the shapefile for the entire county. So we'll click in the area that we want. You see download county GIS data. Again, this is another zip file, so I'm not going to download it because I already have it. But you download it wherever you want it, and then it'll be available, and extract it, and it'll be available for you to use in Civil 3D again. So we're in a different drawing. I already brought in the aerial into this drawing just so that we had kind of an idea of where we are. And we will actually bring in the shapefile as polylines into this drawing. So you go to wherever you saved your zip file or extracted your zip file, and you'll see there's a lot more data, a lot more shapefiles available to you here than in the other download we had. So what we're looking for is the flood hazard, and this is the area which is going to be difficult for us to use. So we'll use the flood hazard lines. You're just going to hit OK. We're just going to bring in the 2D polylines. We don't have to worry about elevations with this. So we could just bring them in just like this. You'll see that this data is actually in a different coordinate system, but it will project into the current drawing coordinate system. So we'll say OK. And it brought in those shapefiles here. So what you could do is you go back to your FEMA page here, And you zoom into your project area to kind of see what that data, what those shapes actually represent. Of course, Esri isn't going to load quickly. Here we go. So then you can see kind of what kind of zones. You got zone A, zone AE, you got actually floodway, you've got storage. So you can take, the easiest thing to do is just to kind of take this information and kind of hatch it out yourself, if that's what you want to do, just so that you have that information in there and can kind of display it. You can figure out if you're in the floodway, if you're in the floodplain, if you're affecting flood storage, and if you have to compensate for any flood storage fill. For this project, we actually did have to compensate for flood storage fill. Just a little interesting side note here. So that's about it. That's about all I wanted to go over with the Dane County example. So we will move on to the Milwaukee County example next. All right, so this Milwaukee County example I'm going to show you here is for another trail project I'm actually currently working on for the city of Greenfield. It's located in We Energy's utility corridor. We're building a trail in there. So we wanted to use whatever we could to minimize the amount of topo survey we needed to get. And GIS is open data is a good source for that. So we go to the Milwaukee County data, and in here it kind of tells you how to download the data, and it also tells you right away what coordinate system we're in. So surprisingly enough, Milwaukee County actually provides their data in the 1983 NAD 1983 State Plains South coordinate system, and our project is actually in Milwaukee County coordinates. So we are going to have to actually translate any data we get out of here into Milwaukee County coordinates so that we can provide our plans in the correct coordinate system. So this is a lot like Dane County. You can zoom into our project area. You're going to click on the tile that you want, and there's two different options. They have an actual DWG file, or you could download the geodatabase file, which is for use in Esri. So cadastral is actually survey data, which is handy. I'm not going to download it here because we don't need it for our example here. But we do want to download the topo planimetric data. Again, same thing. You're going to download the zip folder. I already downloaded it. Put it where you want, and we go to CAD. Oops. So we actually were provided a DWG file in this case, which is actually pretty exciting. Just less steps to go through here. So we download or open this file that we downloaded. Now it wasn't made in DWG format, they just provided it in DWG format, so you still get this warning, not a problem. So here we are. Within here we have a bunch of different data available. We've got our water surface. See, we're a little froze up here for a second. Okay, we're back. Okay, so you can see in here, we've got contour lines. Let's see, these are 3D polylines actually, so they already have elevation information in there. So we know those are ready to create a surface from. We've got edge of sidewalk, edge of trail, edge of road lines. We've got building outlines. We've got all sorts of good stuff in here. The one problem is that, like we said, already established, this is not in the correct coordinate system. So that's why we're going to use this as an example. So what you're going to want to do is you're going to want to set the coordinate system of this drawing to whatever the county said this was in. So we know that the county said this was in the State Plains South coordinate system. So that is what we will set this one up as. State plane, coordinate system, south zone, US foot. 83, we're good. Now we're going to save this drawing. You can do a save as if you don't want to mess with the original file. It's up to you, it doesn't matter. All right, and we're going to close this file right away. And we're going to start a new file. So with this, we're going to use our map wspace task pane again. And we're going to query the drawing we just saved to get that line work into our new coordinate system, into the Milwaukee County coordinate system. All right, first thing we want to do in our new drawing is set the coordinate system that we want our data to be in. So you go back down to WisDOT. You go to Whiskers, Milwaukee County, US foot. We're good to go there. And then we open our map workspace task pane again. Again, we're going to query that drawing that we saved. So we're going to click and drag this right into here. It's important to have that drawing closed because if it's open, it won't allow you to actually bring it into the map workspace task pane. So just remember to do that. All right. So now we go into a query and we are going to define a query here. We're going to go to the location. We're going to say all. We're going to draw. We're just going to execute that query, and it's going to draw all of our data we had, hopefully, into our new coordinate system. All right, I actually stopped recording because Civil 3D was frozen up and was going to wait for it to do its thing offline. It took about 3 minutes for this data to get drawn into the new coordinate system. And then we'll brought in the topo file of our survey just to make sure that it is in the proper coordinate system. We'll load that up here. And you can see that our survey does match up pretty well with the actual edge lines and whatnot that are provided by the county. So the last thing we would do here prior to saving this drawing would be to detach the old one, and then you can do a save as wherever you want to keep this information. Eventually, I would probably break this out, get the contours out of this if you want to use the other information elsewhere, just to make it a little bit of a more simple drawing to use. All right, well, that really wraps up the show and tell portion of the presentation today. Just wanted to quick in closing discuss the data limitations a little bit. Obviously, your design is only going to be as good as the data that you have input into that design. And we don't really know for sure how great the data that you get off of a county GIS site is. Sometimes those surfaces can be 10 years old. So you have to take that into account when you're considering what you're going to use that LiDAR surface for. It's definitely good for preliminary design, good for catch basin modeling, things of that nature. But definitely you're not going to want to use it for curb ramp design. You're not going to want to use it for bridge design. You're going to actually have to get some survey out, some boots on the ground survey to get good, accurate elevation information. And you can tie your survey surface into your LiDAR surface. You just want to make sure that you keep everything straight and keep it clear what data is from where. Also, I kind of self-taught myself all of this stuff using, Googling things, using Autodesk forums, using YouTube videos. If you have any questions on any of this, you can always reach out to me. My email is provided here. Or I encourage you to check out the internet. You'll definitely find what you're looking for and probably more than you need. And with that, I will open it up for any questions that you may have. Thanks.